All right, hello. We're getting ready to jump into Unit 2, Section 5, which is, by the way, the last section of this unit. We're going to have the big test this Friday. But wait a minute, Mr. Metcalf, isn't Friday a e-learning day? Yes, it is. So everybody, the online people and the in-person people, we're all going to take the test on Friday, September 4th, because it is an e-learning day. And I'm going to open the window from like 7 a.m. for you early birds all the way to like 9 or 10 p.m. for you late night folks. So the test is designed to be taken in a 45-minute class. Haven't made them long or anything like that. You will have an hour and 15 minutes to take it before you get kicked out by the computer. So couple of things. What I would do is I'd have everything ready to go, my calculator, my notes, my review packet, any materials you're going to use for that test, and then before I hit start or whatever, I would look at the clock on the wall, add an hour and 15 minutes to it, so you know when you have to have that thing submitted. All right, it's 13 multiple choice questions, not that big of a deal, but it is this Friday. So yeah, which there's a few of y'all still haven't taken the first test, so I'm going to be probably zeroing you all out today if I haven't done so already. And if you're going to take that test, you need to get in touch with me so I can open it up for you to take. And we got to get that in there because I'm going to put zeros in there, and in a few more days, those are just going to be permanent zeros because, I mean, it's kind of ridiculous that the test was almost 2 weeks ago now. Okay, so enough on that. Let's jump right in. I uploaded some guided notes for you for this lesson, again, to take out a lot of the writing. If you didn't have that, you could print it out or you could just copy it down. It's this right here. It's in there. It should be right next to the video that you're watching right now. So, and you'll want that because it's got a nice summary of the properties we're going to be talking about, and that's the main thing. And then just some outlines and pictures. It just save you a lot of writing if you have that. All right, so let's jump right in. We're leading up to the P word in geometry. If you have your mom or dad or older brother or sister, they might say, "Oh well, when you get to geometry, you're going to have to do proofs." Well, today we're going to introduce them to you. Now, if you're talking to a parent, it's probably they're remembering the proofs back in the day, which were much more difficult. We're going to do like easier ones, and today the ones we're going to do are really easy. You won't be scared of these at all. All right, so jumping right in. On your sheet is the different properties of real numbers. You've been exposed to all of these already in your life. You've already been exposed to them. We're going to just sort of bring them to the front of your memory. And to save you some writing, these are the acceptable abbreviations for all the properties. So first you got your add, subtract, multiply, and divide properties of equalities. All right. So whenever you add the same thing to both sides of an equation, you just used the addition property. Whenever you subtract the same thing from both sides of an equation, you just did the subtraction property, and so on with multiplying and dividing. What does that mean? Well, I'll show you. Say you had the equation 2x minus 7 equals 11, something like that. Well, most people would do this. The first thing they would do is they would get rid of that minus 7. They would be adding 7 to both sides. Well, you're allowed to do that because of the addition property of equality. So that would cancel out. You would end up with 2x equals 18, and you just correctly, legally use the addition property of equality because you added 7 to both sides of the equation. The next step you would do is you'd say, oh, well, now I got to get rid of that times 2. So what I would do is I would divide by 2 and divide by 2. And you just now, doing that, you just did the division property of equality because you divided both sides by 2, getting an answer of x equals 9. So you've been using those properties every time you solve an equation. You just didn't know you were doing it, unless you had a teacher who was like on top of their game and really trying to get get ready for geometry, because that's what we're going to be doing here in today's lesson. All right, so these are all the abbreviations. So we just talked about those 4. Then in middle school, possibly 5th grade, but probably middle school, you got hit with these 3 guys: reflexive, symmetric, and transitive property. I'm just going to sum those up real quick. The reflexive property, kind of like the word reflection, says this. It's pretty mind-blowing. The reflexive property says calculator is equal to calculator. Whenever you say something is equal to itself, you're using the reflexive property. And we don't use it very often because it doesn't have a lot of uses, but there is at least one time in the course of this next few days that we will definitely use the reflexive property. And if you didn't catch that, let me show it again. There's no tricks. It's just make sure everybody gets it. Calculator is equal to calculator. That's all the reflexive property says. All right. Now, the second one is the symmetric property. The symmetric property is a little more advanced, not much, but the symmetric property says if calculator equals marker, then, check this out, marker equals calculator. See what I did? I just flipped them. The symmetric property says you're allowed to do that. You're allowed to switch the order. Now, why would you ever need this? Okay, well, not a lot of times, but you could say you did a math problem, an equation or something, and you got down to the end and it ended up saying something like -3 equals y. And you're like, wow, I don't really like the number being on the left and the variable being on the right. I want it the other way around. Well, you can simply switch it. You can say y equals -3, and you just correctly use the symmetric property. All right, the symmetric property allows you to change the order. Okay, now my favorite one is the transitive property. And this is the one I was trying to get you all to see was very similar to the law of syllogism from the last lesson. Now here's how this works. The transitive property says, and I need 3 items for this one. So here we go. It says if calculator equals marker and if marker equals hand sanitizer bottle, then since marker was in both of them, it was in the first one and it was in the second one, we can jump from calculator equaling hand sanitizer bottle. All right, y'all see that? It's like in middle school or late elementary school, your teacher said if A equals B and B equals C, then A can cross over B to equal C. And that's what trans means. Anytime you see the prefix trans, it means something crossing over. Transcontinental Railroad, you learned about that in middle school. That's the railroad. We finally connected the East Coast to the West Coast. It went with a big, long railroad with the Golden Spike somewhere out there in the West. That last spike to connect them. Big historic moment in our country's history. Transatlantic flight. Transatlantic flight means you are crossing over the Atlantic Ocean. You're going from, maybe New York over to Paris or London or something like that. Transatlantic flight. Okay, so that's trans. Crossing over from A, crossing over the B all the way to C. A can equal C. All right, now these last 2 guys, you learned about these last year in Algebra 1. Substitution property. All right, if we go back to this example, say you did a problem and you found out that in that problem y equals -3. All right, I don't know. I hope this is not glitching out on you at home. I keep glitching out on my screen. I hope it's smooth as silk on your all's end. But okay, so y equals -3. How you could use the substitution property is if early in the problem they said something like maybe the measure of angle ABC is equal to, -7x plus 20. All right. So maybe in the beginning of the problem they said something like that. Oh, y. My bad. Let's do y. Freestyling. Okay. And then we get y equals -3. Then what we could do to find out the measure of angle ABC is we say, okay, we're going to, since y equals -3, we're going to replace or substitute a -3 in for y. So now it's not -7 times y, it's -7 times -3 plus 20. So let's see, -7 times -3 is 21 plus 20, so 41. And now we know the measure angle ABC is 41. All right, so that's how the substitution property works. Once you find that two things are equal to each other, then you could substitute one in for the other. All right, so that's how that works. And then the last one, this is probably the most important property you learned in Algebra 1, that's the distributive property. That happens when you've got a situation like this. Say you got it could be a variable on the outside. Usually it's a number, but it could be a variable. You got something like 5 and then parentheses like maybe 2x minus 4, something like that. If there is no plus or minus sign in between the 5 and the parenthesis, if it's mashed, I call it mashed up against that, this is the distributive property, all right? That means this 5 is wanting to distribute to everybody in the parentheses. Everybody, every term, all right? I have 2 terms, which is the usual. You could have 1 term, you could have 10 terms. It doesn't matter. But he being mashed up against the parentheses, he's going to want to get in and multiply with everybody in the parentheses. So a lot of teachers draw these arrows. They'd say, okay, 5 times 2x, that would be 10x. And then 5 times the -4 or -4 would be -20. And that's how the distributive property works. So that's just a quick recap of the properties we're going to be using in here today. That's leading us in to our first proof coming up here in just a moment. All right, so got the properties recapped. Here's their abbreviations. Did a little tutorial on how they work. Let's move on. Okay, we got some vocab words. Here's the P word, proof. P word's a convincing argument that uses deductive reasoning, okay? When you prove something, then it's absolutely true. We talked about how deductive reasoning always leads to a logical conclusion. So does a proof, all right? So that's what we're going to be doing today. There's 2 types that we talk about in here. We have the algebraic proof, which is just an algebra problem, but each step we back up the what we did in each step with a reason or a justification. And then there's the geometric kind, which we'll do one today, but we'll get heavy into that in a later unit. It might even be unit 3. I can't remember for sure. But there's 3 different formats that we talk about for them. So there's 2 types, algebraic and geometric, and then there's 3 formats. We're always going to do the 2-column proof format, and you'll never believe why it's called 2 columns. It's called that because we organize it in 2 columns. It's also known as a formal proof. I probably won't say that term beyond today, but there is, yes, an informal proof as well, but we don't really talk about that too much. And a 2-column proof, it's a type of proof that lists each statement on the left and the justification or reason for each statement on the right. So this is not just somebody blowing loud. This is somebody making a statement and then they're backing it up with a reason. So if they do that each time and back everything they say up with a reason that is accepted, they've just proven something, all right? And we're going to do that. No, I think we got a screen ahead of it first. So here we go. Algebraic proof. And remember, you all can pause as needed, all right? Especially if you don't have the notes out in front of you. You got a lot of writing ahead of you. All right, so algebraic proof. A proof that is made up of a series of algebraic statements. So we're going to solve like a multi-step equation, just like you've done numerous times in Algebra 1, but then we're going to back up each step with a reason why we're allowed to do that, all right? So let's just try a few like steps in a proof. We got 3 examples here. I skipped number 3. On your paper it probably says optional, but what you want to do is find out what changed from the first step to the second step. So in the first step I got 4 plus -5 equals -1, And then in the second step, I have kind of the same thing, but something has changed. So the change is what gives away what property I used. So in the second step, I've got x plus 4 plus negative 5 equals x minus 1. And give you a few seconds to think about which property just occurred there. The change is from this step to this step, an x was added to both sides. And me saying that out loud should give it away. The fact that we added an x to the left and to the right should tell you that I just used the addition property of equality, APE, all right? That we added an x to the left, we added an x to the right. Okay, and this one will be easy if you were paying attention earlier. I started off with 5 equals y, and then I switched it to y equals 5. So all I did was change the order, and when you do that, you're using the symmetric property. Symmetric property literally allows you to change the order, all right? Any questions on that one? And like I said, we skipped number 3 and we jumped to this one. You'll hear this one just listening to the cadence of what I'm saying probably. Number 4 says, if angle O is congruent to angle W and angle W is congruent to angle L, then angle O is congruent to angle L. All right. So what I did is I went from O to W, W to L, and then since W was repeated in both statements, I jumped from O to L. So I know everybody at home by now, long before I explained it, probably knew that that was my favorite of the properties, the transitive property. Transprop. Oop. That's an N. Transprop. Okay. Any questions? Because I think we're about to do our first ever proof on this next slide. And like I said, all the scariness of what a parent or an older brother or sister has told you about proofs, you'll see it wash away, at least initially, because these first ones are pretty easy. So boom, here we go. All right, we're given something, and in this case, in an algebraic proof, we're usually given an algebra problem, right? And you'll say, oh yeah, that's easy. I did a lot of those in Algebra 1 last year, okay? But what your teacher probably didn't do last year when they gave you a problem like this is tell you what the answer should be. We're going to try to prove that x should be negative 18. So that probably didn't happen in algebra class. They said, hey, here's a problem. They said, do it. See what it comes out to be. Well, in geometry, we are going to tell you what it should come out to, and you're proving that. So, like I said, with an algebraic proof, you literally just do the proof over here do the problem over here like you did normally, writing out the steps and stuff. And then the only difference is we've got it in this little 2-column, and apologies for my cursive, it's not very good. That says statements. And then, so we're going to do the problem over here in the statements, and then we're going to back up each step with a accepted reason, all right? Now, the first thing is always given, all right? You're given a problem or some information. And when we do the geometric one here in a moment, I'm going to apply it to a crime scene and a court case kind of thing, just to make it a little more jazzy for you. But we always start with the given, all right? I've seen some worksheets try to get fancy and do a few steps, and then they insert a given down here low. No, don't do that. Just whatever they give you, just put that in there first. And your reason for it is it was literally given to you. All right, you didn't create any of this stuff right here. It was given to you. All right, so enough on that. How would you solve this? And you've already got it in your head that it's x probably better equal negative 18, because that's what they told you. So if you solve this problem, I'm assuming everybody would know that you want to take this negative 5, who's on the outside of the parentheses, and multiply him by the terms on the inside. So negative 5 times x, that would be negative 5x. The negative 5 times the 4 would be negative 20, and it still equals 70. Now, with those little arrows and stuff going around, and I think just the look of this, I think everybody knows what I just did there, and why I'm allowed to do that is because of the distributive property. All right, so we're going to call it dist prop. All right, I just demonstrated the distributive property. Okay, so now we found out today there is multiple ways to swing this dead cat. Matter of fact, I taught 3 classes today. All 3 of them went in a different direction from this step right here. The step I would do, it makes the most sense to me, I call it the Metcalfe rule. We're trying to solve for x, so we want to get rid of these guys. I'm going to get rid of the minus 20. So I'm going to add 20, and then to be equal, I add 20 to this side. Now this is scrap work, so it literally goes in between statement 2 and 3. It's scrap work, so don't put a 3 here. The 3 will be the result of adding 20 to both sides. And the result of that would be, that cancels out, so I'd have negative 5x equals 90. So the result of adding 20 to both sides goes on line 3, and I think everybody knows, since I added 20 to both sides, I just used the addition property of equality again, APE. Now, we're one step away from nirvana. All we got to do is get rid of this times negative 5. Please don't add 5 right here. That is not x minus 5, that's negative 5 times x. And to get rid of times negative 5, I think everybody knows we should divide both sides by negative 5. And again, that's scrap work right there, so it goes in between 3 and 4. The negative 5's cancel out, leaving us with x equals, and lo and behold, 90 divided by negative 5 is negative 18. And since I've said it a couple times, I divided both sides by negative 5. I think you all know that I just used the division property of equality. And boom, there you go. For most of you, that was the first ever proof you've done. In class today, we all took selfies with it, because that was our first of many proofs we're going to do here in this semester. So yeah, we took a selfie with it. We're going to put it on Tweetstagram tonight and have a good document of us doing our first ever proof. Any questions on that? Again, shoot me an email. I think I've explained it as well, as easily as I could. It's pretty basic. Here's the math problem over here. Here's me justifying each step. Nobody's going to argue with me in this situation that x equals negative 18. I've just proven it literally. All right, moving on. Okay, on this slide, we got a skip slide, which always brings out a happy face. All right, good job. And back in the day, we used to, using the formula for Celsius, prove the formula for Fahrenheit. Usually a pretty juicy problem. We're going to skip it for now. Maybe later on we'll do something like that. And then the geometric proof, we're going to use these 3 guys a lot. And at this point in your guided notes, if you're following along in your guided notes, you're going to say, well, didn't we already talk about these 3? We did. Technically, we talked about them as pertaining to numbers and variables. They just want me to remind you that these 3 properties also work for things, all right? Not just markers and hand sanitizer and calculators, but for angles and segments and other things like that. The reflexive property, angle A is still congruent to angle A. That's still the reflexive property. And symmetric means you can switch the order. If angle A is congruent to angle B, you could rewrite it as angle B is congruent to angle A. That's still correct. The symmetric property still works, and so does the transitive property. They don't only work with numbers and variables, they also work with geometric figures, those 3 properties. All right, and that's all they just wanted me to say on that. Okay, now I think we're ready for an actual geometric proof. Okay, now here's what's going on. On your guided notes, you'll notice all this stuff here is listed up here underneath the word given, or with the word given, meaning these are things that were given to you for free. You didn't have to figure them out yourself. They were provided for you. They're like hints. And again, I'm going to tie this to like doing a murder scene, crime scene. Imagine there's been a murder or something and a detective gets called to the scene. there's some things that are just given to him, like maybe there's a dead body with a knife stuck in it, or the victim still has his wallet with money in it still in his pocket, and then maybe the time of day when the crime happened, or the location, like maybe it's on the sidewalk in front of JC or something like that. Those are things that were given to the detective. He didn't have to figure those out. They were just provided to him, and so that's his starting point. All right, he's got some information just given. Now, so it's all up here, but we do need to write it into the actual proof. All right, and I highly recommend you always, whatever's given to you, just start off and put that in there first. All right, I don't know why you would save some for later. I've seen it done a couple of times on some worksheets. I just think whoever made those problems were trying to be cute. I would just put all your given up there first. Now, if there's a picture that goes along with the problem, you want to make sure every piece of information that was given to you is now placed onto the picture, because 90% of us, we're visual learners. We learn best by seeing it, and seeing it separated and not together just sort of might hinder us. So let's make sure we have everything that's in here on our actual picture. So I'm looking at the first thing, and it says angle FGJ is congruent to angle JGK. So FGJ is this guy right here, and he's got a 6x plus 7 in him. And it's saying that he's congruent to the one right next to him, JGK, his adjacent buddy, so to speak. So to indicate that this angle and this angle are the same, I'm going to put a red swoosh on him and a red swoosh on him, because they told me those two are congruent to each other. All right? Now, they also told me some other stuff. JGK again, that's that one on the right that I put a swoosh on. He's also congruent to KGH. That's his other adjacent buddy with the 8x minus 5 on him. So if he and he are the same, and he's got a red swoosh, that means I should be able to put a red swoosh on him, which basically tells all of us, because we're geometry students, tells all of us that all three of those angles are the same. But you got to keep in mind, to the average person who doesn't have a geometry class or Mr. Metcalf, they might not know that those swooshes mean all three of them are the same. So we're going to have to explain that to our jury. All right. So going back to this being a court case, the detective gets all this given information up here, but we do have to write it into the proof, because the proof represents what is the evidence that's introduced into court, into the trial, so to speak. All right. So if we don't put the given in there, the jury never sees it. The jury doesn't know what's this case about, and then the evidence, the given, kind of leads them to know, oh, this is a murder case, because we're talking about a dude with a knife in his body, and all that kind of stuff. So we need to tell the jury that stuff as well, not just let the detective see it, but actually the jury needs to hear it as well. So now, and these two things were already marked, the 6x plus 7 and the 8x minus 5, they're already there. So my drawing is up to date. All my information has been inputted into the drawing, so I'm ready to start doing my detective work. Now, the cool thing about proofs is you always know what you're trying to prove. They tell you. And we're trying to prove that x equals 6. So if we don't get x equals 6, we did something wrong, all right? Or this is not an invalid proof. And I'm not going to give you any of those. They always should work out. So first thing we want to do, if we're trying to get to x equals 6, we got some algebraic expressions. A lot of teenagers in 2 of the 3 classes today, they jumped to step 3. They forgot the baby step. One class did know the baby step, and that is this. Right now, most classes want to jump in and say 6x plus 7 is equal to this, because eventually they're going to be, right? 6x plus 7's got a swoosh, 8x minus 5's got a swoosh, but we haven't said that yet. We haven't explained that to the jury, all right? And you want everybody, if you're trying to put somebody away for murder, you need all 12 jurors to understand what you're talking about. You don't want to go over their head or anything like that. You want to explain everything. You want to lay it out nice, neatly, and understandable. So we're going to show a baby step, and it is required that you do this. You can't just jump into saying 6x plus 7 equals 8x minus 5, even though we know it does, but that's because we're geometry students. We know that. We're going to have to show a baby step. We're going to say, we're going to make the jump from angle FGJ, angle FGJ, he is congruent to angle KGH because of what? How do we know we can make that jump? Because FGJ is congruent to JGK and JGK is congruent to KGH. What did I just say? What property did I just give you just a few minutes ago that says you can make that jump if you have something in common? Absolutely. The transitive property. Or as we're going to call it, the trans prop. All right? You can jump from A to C if A and C are both equal to B. And in this case, we jump from this angle to this angle because they both are equal to JGK. So now I've got that. That's a very necessary baby step in this problem. If you leave it out, it'll be like the criminal getting free on a technicality because you left out a very important step. Now I can replace these angles with their values because I know both of them's values. I know FGJ, his value is 6x plus 7, and I'm going to make that equal to KGH's value, which is 8x minus 5. 8x minus 5. Now I used the word replace so I wouldn't give away what property I just used, but what's another word that means replace? That's absolutely right. I just used the substitution property. Since the measure of angle FGJ is equal to 6x plus 7, I can replace angle FGJ with 6x plus 7, and that's what I did. And I did the same thing for that angle. So I used the substitution property. And now the rest is just like what we did on the previous one. It's just a glorified algebra problem, and I got to justify each step. So most people, and actually I think this is the one where we went in 3 different directions. I'm sorry, not the previous one. This is the one where we went in 3 very different directions. As you all know me, I do the school bully style. I see a 6x on the left, a 8x on the right. The school bully would go after the smaller one, so he's going to do a minus 6x, minus 6x. And again, that's scrap work. That goes in between steps 3 and 4. The result goes on line 4, and the result would be that's canceled out. So I have 7 equals now 2x minus 5. And what I just did there is I subtracted 6x from both sides, so I think you all know that's the subtraction property of equality, SPE. All right, now here's the x I'm going to solve for, and I got 2 things in the way, so I'm going to get rid of that minus 5. I'm going to add 5 to this side. I'm going to add 5 to this side, and again, that's scrap work. It'll be the result that goes on statement 5, and the result would be 7 plus 5 is 12 equals 2x, and then the minus 5 is canceled out by the plus 5. And so since I just added 5 to both sides, I just used the addition property of equality. All right? And one more step to having x solved for. I don't know if we just have one step left, but we're going to get rid of this times 2 by dividing by 2 and dividing by 2. And then the result will go on line 6. And the result of this, 12 divided by 2 is 6. And the 2's over here cancel out. So I got 6 equals x. And I think everybody knows at this point I just did the division property. I divided both sides by 2. So I did the division property. And a lot of people would say, oh, congratulations, we're done. We've got 6 equals x, and we said we were going to prove x equals 6. Well, hold your horses, because it needs to be exact. It needs, to the order. Like if I said, Mr. Smith is guilty of murder, and I'm going to prove it, and then at the end I said all Yoda-like, murder is guilty of Mr. Smith. I say it backwards. It might confuse some people on the jury, and they'll be like, wait, you said Mr. Smith is guilty of murder. Now you're saying murder is Mr. Smith guilty? Yeah. So you don't want to even leave the order different than what you said. So they said, we're going to prove x equals 6. We've proven that 6 equals x. And again, being geometry students, we know that's the same thing. But we're going to go ahead and switch it for them. We're going to say, okay, yeah, you're right. We said we were going to prove x equals 6. So we flip it over to that. And that's the whole reason why we have that one property that allows us to change the order. Remember that one? That was the symmetric property. So we just used the sim prop. And now everything is chilly chill because I've proven exactly what I said I was going to prove. So nobody's confused. Everybody's pretty happy with this. Backed up every step with a property. Nobody can argue with it. We're done. Awesome. All right. I think we got maybe one more screen to go. Let's check out and see what's going on. Okay. Optional. Skip this year. We're going to skip this one this year and move on to, on the very back of your guided notes, I got this. Vertical angles. You don't get to forget them. Yeah, it was a concept in Unit 1, but it is going to follow us all the way through to June. All right. So you can't ever forget it. And if I'm bringing it up here right now, that's because it's probably going to be one of the problems on the test. It's such an important concept. I'm going to keep testing it, make sure you know it. All right, so we have a perfect x. And whenever you have a perfect x, you can have vertical angles. Now, we talked about vertical angles don't necessarily have to be up and down. I know that's confusing because that's what vertical means, up and down, basically. But vertical angles can be up and down, but they can also be horizontal as long as you've got a perfect x and you've got angles across from each other. And the key is they're always congruent. So this 3e plus 10 is equal to the 5e minus 2. So that's what I'm going to say. I'm going to say 3e plus 10 is equal to the 5e minus 2. All right, so we're going to take a few seconds and solve that. Again, this is a school bully situation. I'm going to go minus 3e minus 3e. And I'm going to get 10 equals 2e minus 2. And then I'm going to get rid of the minus 2 by adding 2 to both sides. That cancels out, so I get 2e equals 12. And to find out what e is, I got to divide by 2, divide by 2. Hope I'm not going off the bottom of the screen. Nope, I'm still on there. Awesome. So at the very bottom, you would get the 2's canceling out, so you'd end up with e equals 12 minus 2 is 6. All right, so e is 6. Now, but Mr. Metcalf, how are we going to find b? Because you don't have any markings on his vertical partner. All right. Well, that's because there's really two relationships that I need you all to know are not going to go away. Vertical angles, super important, always going to be with us, but so is this relationship. All right? These two guys are next door neighbors on a line. That's a vocab word we learned a while back. Next door neighbors on a line are, yes, linear pairs. Now, the most important thing about the linear pairs is not that they are linear pairs, but what that means to us mathematically. Mathematically, if you have linear pairs, you have 180 degrees, all right? Check this out. A long time ago, we had a lesson with a big yellow circle. I told you I was going to keep referring to it, and there I'm referring to it again. Hope you all can see it. I just drew a big yellow semicircle because when I had the circle, you all told me it's 360 degrees. I drew a line through it, and you said, well, okay, that means there's 180 underneath it. There's 180 above it to get the 360. So these two guys added together have to be 180. But Mr. Metcalf, how can I solve that? He's an E, he's got a B. There's two variables. Well, remember, we just figured out that E equals 6. So using the substitution property, I can put that 6 in for E. So now it's no longer 3E, it's 3 times 6, which is 18, plus 10 means this angle is 28. All right, so that angle is 28, and this angle is still 10b plus, where were you in 62? And there's a couple of ways to swing this dead cat right here. A young man in an earlier class today said, well, if he's 28, I know he's got to be 152 to make 180. So you could say this equals 152 and solve that. I don't want to go there right now. It's a shortcut, yes, but not by a whole lot. And I want to just keep us going with linear pairs and adding up to 180. Less you have to remember, okay? So this still has to equal 180. He's 28. He's this algebraic expression. So let's just go ahead and say 28 plus this angle, 10b plus where were you in 62, plus 10b plus that, still has to equal 180. All right, I'm going off my screen a little bit. Can you read that? Yeah, it looks like you can still read it. So yeah, and that's a b, now not 106. Poor choice of variables. Makes, especially for somebody like me, I can't make a b not look like a 6 very well. So we start combining like terms because the 28 and the where were you in 62 are like terms. They combine into 90 plus the 10b, try to make that look like a b, equals 180. Still looks like 106 to me. Man, that's confusing. All right, so now to find out what b is, we subtract off the 90, subtract off the 90, and we get 10, and I'm going to say it again, b equals also 90. And all we have to do now is divide off the 10, divide by 10. By the way, using the division property of equality there, and the subtraction property of equality there, cancels out. We get b equals 90 divided by 10 is simply 9. All right, there's our two answers. We're all good. If you wanted to chickadee check, you could take the 9, put it right here. I'll just go ahead and do that since we're about done anyway. I'll put the 9 right here. And as you remember, we said it should come out to be 152 because that's what you need to add to 28 to make the 180. So 10 times 9, that would be 90, plus the where were you in 62. Sure enough, that comes out to 152. So I can feel pretty confident because those two numbers add up to 180. Any questions, just zip me an email. Be ready. We're going to be taking that test on Friday. Online people and in-person people. We're all going to take it Friday. And hopefully everybody's going to get an A or a B on it. And those of you who haven't taken the Chapter 1 test, all right, I'm probably going to send out an email to remind your parents you haven't taken it. Get in there and take it. Email me if you need to, if you're having trouble getting to the tests. I'll see you real soon. Actually, the next week, everybody will be doing these online lessons for a couple of days while we're on that e-learning week. So see you virtually. Bye-bye.